All right, welcome to the Explainer. Today, we're going to crack open a really core idea in Python, what I like to call its golden rule.
Now, you've probably heard this phrase a million times, right? It's all over the tutorials. Everything is an object. But what does that actually mean when you're sitting down to write code? Well, that's what we're going to dig into.
So in a lot of other languages, you've got this split. There are simple things like just a number, and then there are these big, complex objects. Python, it just says, nope, not doing that. In Python, there's no such thing as a bare value.
I'm serious. Everything. That integer, 42, it's an object. The string hello, that's an object too. Even a list, or get this, none. They're all objects. And what that really means is that each one is an instance of a class, packed with its own built-in data and abilities. Okay, that's a pretty bold claim, right? So let's not just take my word for it. We're going to play detective and put this theory to the test. Let's see if this everything is an object rule actually holds water. First up, let's start with something super simple, the number 42. I mean, it just feels like a basic value, doesn't it? It's just a number. What more could there be?
So here's the big question. Is it just a value, or is it a full-blown object with stuff hidden under the hood? Let's use Python's built-in tools and find out for ourselves.
And boom, right away, the type function gives us our first piece of evidence. See, it doesn't just say integer, it says class int. That little word, class, is everything. It's telling us that 42 isn't just a value, it's a living, breathing instance of the integer class.
And because it's an object from a class, it has superpowers, or well, methods. We can actually call a method like bitLength directly on our number. It tells us how many bits it takes to store it. You just can't do that with a plain old bare number. That's object behavior right there.
So, there you have it. The evidence is pretty clear. Case closed on this one. Even a simple number in Python is an object.
All right, numbers are objects. Got it. But what about text? You know, like a string? Let's see if the rule applies there too. And would you look at that? It's the exact same story. We run typey on our string, and sure enough, we get class string. And because it's a string object, it comes with a whole toolbox of handy methods like upper, which, well, you know what that does.
So yeah, the pattern holds. A string in Python is definitely an object. The rule is looking pretty solid so far.
Okay, so data is an object, but the rule goes way deeper than just data. And honestly, this is where things start to get really cool and powerful.
Think about it. It kind of makes sense for data, right? A number has properties, a string has properties. But a function? Isn't that just a bunch of instructions? A recipe? Surely that can't be an object, can it?
Well, this is one of Python's biggest tricks. A function isn't just a static block of instructions. It's what we call a first-class object. And that's a fancy way of saying you can treat it just like any other piece of data. You can pass it around, stick it in a list, whatever you want.
And of course, we can prove it. Look here. We define a function called greet. If we check its type, yep, class function. And get this, it even has attributes, just like our number and string did. We can literally ask the function for its own name, and it'll tell us, greet.
Okay, prepare to go a little deeper down the rabbit hole. What about the class itself? You know, the blueprint you write to create your own objects. You guessed it. In Python, the class itself is also an object. Its type is literally type. It really is objects all the way down.
So, at this point, you might be thinking, okay, that's a neat trick, but why should I care? What's the big payoff here? Well, it turns out this one single rule is the secret sauce behind some of Python's most powerful and well-loved features. It really boils down to 4 huge advantages. First, you get amazing consistency. You use the same dot notation on everything. An integer, a string, a custom object, a function, it's all the same. Second, it gives you incredible flexibility. You can toss functions around like they're any other variable, which is a total game changer. Third, this unlocks serious power. Advanced features like decorators and metaclasses, they only work because of this object model. And finally, you get introspection, which is the ability to inspect any object at runtime and figure out what it is and what it can do. It's like having X-ray vision for your code.
And that's really the heart of it, because Python treats everything as the same fundamental thing, an object. The whole language becomes incredibly consistent and predictable. It's a huge part of what gives Python its famous elegance and strength.
So when you think about it, almost everything comes back to this one single rule.
It's this simple but profound idea that really is the foundation for what makes Python feel like, well, Python. But that does leave us with one last kind of mind-bending question, doesn't it? If an object is made from a class, and a class is an object made from type, then what in the world creates type itself? It's a fun little puzzle that just shows how deep this whole thing goes. Something to think about for next time. Thanks for joining me on this explainer.